Hello dear students, now I am going to discuss Cambridge A-level chemistry October-November 2022 paper 21 and paper 23 written paper. Let's move. Number 1. Atoms with nuclei containing an odd number of protons tend to have fewer isotopes than those with an even number of protons. Number A. Gallium has two stable isotopes, gallium 69 and gallium 71. Their mass number 61 and mass number 71. Complete table 1.1 to show the number of protons, neutrons and electrons in the two stable isotopes of gallium. So here gallium 69 atomic number, gallium atomic number 31, number of proton means 31, and number of neutrons will be mass number minus proton number, 69 minus 31, 38. Then number of electrons will be equal to number of proton, as this is neutral atom. So number of proton 31, also number of electrons 31. Then gallium 71 mass number, proton number same 31, and number of neutrons will be mass number 71 minus 31, 40. Number of electrons equal 31 as same number of proton. Next, define relative atomic mass. This is the definition. The average mass of the atoms of an element compared to the unified atomic mass unit. This is the definition of relative atomic mass, or you can write the average mass of one atom relative to 1/12 mass of carbon 12, or you can write the average mass of the atoms of an element compared to the unified atomic mass unit. Next, number 3, the relative atomic mass of gallium Ar is given 69.723. The relative isotopic masses of gallium, isotopic masses 69 and 71 are given 69 relative isotopic masses 68.926 and gallium 71 70.925. Use this information to calculate the percentage abundance of gallium 69 in elemental gallium. Show your working. Assume that the element contains only gallium 69 and 71 isotopes. Give your answer to 4 significant figures. Now you see, Ar is given relative atomic mass 69.72 equal, let gallium 79 abundance x, so gallium 71 will be 100 minus x. Total abundance is 100. So AR equal mass into percentage or abundance, mass times abundance, plus 70.925 times 100 minus 6 divided by 100. This is the formula of relative atomic mass. Relative atomic mass equal relative isotopic masses times percentage or abundance plus relative isotopic masses times percentage divided by 100. This is the formula. Then you will get X equal 60.13%. This is the percentage abundance of gallium. Now next, B1, potassium also has two stable isotopes. Both isotopes have same chemical properties. Explain why both isotopes of potassium have the same chemical properties. Chemical properties depend on the electronic configuration. So they have the same electronic configurations. Both isotopes have same chemical properties. Why? Because they have the same electronic configuration. That's why their properties are same. Now number 2, state the full electronic configuration of an atom of potassium. And you know potassium 19 proton, atomic number 19 means potassium has 19, proton number 19 means 19 electrons. Electrons is 19. Potassium has 19 electrons. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Total 19 electrons. 2, 4, 10, 12, 18, 19. Next, the first, second and third ionization energies of potassium are 418, 3070 and 4600 kilojoule per mole respectively. Use this information to explain why potassium is a group 1. And you see, to remove one electron, first electron, it needs 418, but when remove second electron, more energy is needed. This gap is more, 400 to 3000. So there is big jump between first and second ionization energy. Why? Second electron is removed from inner shell. Second electron is removed from inner shell because potassium second shell, third shell, fourth shell. Fourth shell has only one electron. So this is the when one electron is loose, this is first ionization energy. Then to remove second electron, this is the close to nucleus. That's why there is a big jump between first and second ionization energy. Then now number 2, magnesium shows reactions typical of group 2 metal. A. Draw a labeled diagram to show the bonding in magnesium metal. You know magnesium is a metal, so metallic bond present. This plus are positive ions and negative sign is delocalized electrons or mobile electrons. So you know metallic bonding, the attraction between positive metal ions and sea of delocalized electrons. This is the labeled diagram. Then B, you see here some reactions. Magnesium reaction 1 reacts with hydrochloric acid to produce magnesium chloride, and reaction 2 magnesium carbonate reacts with hydrochloric acid to produce magnesium chloride. Magnesium chloride reacts with hydrochloric acid to form magnesium hydroxide, and reaction 4 is showing magnesium carbonate, if you give heat, breakdown to form magnesium oxide. Now you are asking 1, identify the other products of reaction 1 and 2. So reaction 1, you see magnesium reacts with hydrochloric acid, and you know metal reacts with acid to produce salt. Magnesium chloride is salt plus hydrogen. So reaction 1, other products will be hydrogen, H2, or you can write hydrogen. Reaction 2, magnesium carbonate reacts with acid, and you know any metal carbonate reacts with acid to produce salt plus carbon dioxide plus water. So in reaction 2, other product will be carbon dioxide and water. Then reaction 3 is used to form a precipitate of magnesium hydroxide from magnesium chloride. So state why calcium hydroxide would not form a precipitate of barium hydroxide from barium chloride, and would not form a precipitate because barium chloride to barium hydroxide will form, but barium hydroxide is not precipitate. Barium hydroxide is soluble. Barium hydroxide is soluble, so it is not solid, it is not precipitate. That's the reason. Number 3, state the type of reaction that occur in reaction 4. Reaction 4, you see, this is known as thermal decomposition. Breakdown of a compound by supplying heat. Breakdown of a compound by giving heat is known as thermal decomposition. You see reaction 4. Reaction 4 is magnesium carbonate give heat to form magnesium oxide plus carbon dioxide. So reaction 4 is known as thermal decomposition reaction. Next, see, 1 centimeter cube of magnesium chloride is placed in a test tube. A few drops of silver nitrate aqueous are added, followed by 1 centimeter cube of dilute ammonia. So state in full what is observed in this experiment. Okay, first you see this is the chloride ion. So chloride ion reacts with silver ion. This is the test for chloride ion to form AgCl. AgCl is known, you know, AgCl solid is the white precipitate. White precipitate solid. Chloride ion reacts with silver ion to form AgCl solid. So you would see white precipitate is formed, white precipitate is produced. Then this precipitate is dissolved on addition of aqueous ammonia solution. Chloride ion reacts with silver nitrate to produce white precipitate of silver chloride. This silver chloride is soluble, dissolved in ammonia solution. Next, number D, when 1 centimeter cube of magnesium chloride is added to 1 centimeter cube of bromine in a test tube, the solution remain orange. So bromine plus magnesium chloride so the solution remain orange. Bromine, aqueous bromine is known as aqueous bromine is color in orange. So here bromine is less reactive, so bromine is a less reactive, or you can write bromine is weak as an oxidizing agent, so bromine cannot oxidize chloride ion. Bromine is a weak oxidizing agent. Bromine is a less reactive, so bromine cannot oxidize chloride ion. That's why bromine aqueous solution orange color remains same. No reaction happen here, no reaction occur here. So this the answer will be bromine is a weak as an oxidizing agent. Bromine is a weak oxidizing agent than chlorine. That's why bromine cannot oxidize chloride ion. That's why bromine color remains same as orange. No color change occur here. Next, number 3, some common chlorides of period 3 elements are shown in the list: sodium chloride, magnesium chloride, aluminum chloride, silicon tetrachloride, phosphorus pentachloride. From the list, identify number 1, all the chlorides that have giant ionic bond, ionic structure in the solid state. And you know, sodium chloride is a giant ionic magnesium chloride. So answer will be sodium chloride and magnesium chloride. Number 2, all the chlorides that react vigorously with water to form strongly acidic solution. And you know, aluminum chloride reacts with water to produce hydrogen ion. This is acidic solution. And silicon tetrachloride hydrolyzes to produce silicon dioxide and hydrochloric acid. So strongly acidic solutions form. Also, phosphorus pentachloride reacts with water to produce phosphoric acid. So all these 3 reacts vigorously with water and form strong acidic solutions. So answer will be aluminum chloride, silicon chloride, phosphorus chloride. Number 3, the chloride that dissolve in water to form a neutral solution. And you know, sodium chloride dissolve in water to form neutral solution pH 7. This is the answer is sodium chloride. 4, the chloride form from the element with the highest melting point. Here silicon tetrachloride is produced from the element silicon. And you know, silicon is a giant covalent, so it has the highest melting point. That's why this is the answer will be silicon tetrachloride, because silicon tetrachloride is produced from silicon reacts with chlorine. So here silicon element has highest melting point. Next, B. Sodium chloride is one product of the reaction of chlorine gas and cold aqueous sodium hydroxide. Identify the other products. And chlorine gas reacts with cold sodium hydroxide. Three products is formed. One is sodium chloride, other is sodium chlorate 1 and water. So identify the other products. One product is sodium chloride. You are asking to find out the other products. So you have to know, chlorine reacts with alkali in cold condition to produce sodium chloride, sodium chlorate 1 and water. Then C. Phosphorus pentachloride reacts with alcohol to form chloroalkane. Alcohol reacts with phosphorus pentachloride to form chloroalkane. Number 1. Identify this type of reaction. This is a substitution reaction. Why? Because OH group is replaced by a chlorine atom. So if one atom of group of atom is replaced by another group of atom or one atom, this type of reaction is known as substitution reaction. So when alcohol reacts with phosphorus pentachloride, chloroalkane is produced. Alcohol functional group OH is replaced by the functional group of alcohol is the functional group of OH of alcohol is replaced by chlorine atom. That's why this type of reaction is known as substitution reaction. Next, draw the structure of the organic product formed in the reaction of an excess of phosphorus pentachloride with butane 1,3-diol. So butane 1,3-diol 3 carbon contains one OH group. Also number 1 carbon contains one OH group. This hydrogen, these are all hydrogen. This is the butane 1,3-diol. So when butane 1,3-diol reacts with phosphorus pentachloride, this chlorine will be replaced by this alcohol group will replaced by chlorine atom. This alcohol group will be replaced by chlorine atom. Haloalkane will be produced. So this is the 1 carbon, 2 carbon, 3 carbon, 4 carbon. 1 carbon contain one chlorine atom, 3 carbon contain another chlorine atom. So 1,3-dichloro butane will be the product. Next, sulfur acid reacts with chlorine to form several different chlorides. The most common are H2Cl2, HCl2. HCl2 forms when sulfur reacts with excess chlorine. So reaction 1, sulfur reacts with chlorine to form H2Cl2, and reaction 2, H2Cl2 reacts with chlorine to form 2. Both reaction are delta H is negative. So you are asking number 1, HCl2 is a cherry red liquid that reacts vigorously with water to form an acidic solution, and use this information to deduce the bonding and structure shown by HCl2, sulfur dichloride. Explain your answer. So structure will be simple. Why? Because this is a liquid. Simple. Why? Because it has a low melting point. That's why it is liquid. Bonding will be covalent because it is hydrolyzed, as reacts vigorously with water, that means hydrolyzed. So bonding will be covalent because it is hydrolyzed. Next, calculate the energy change of formation of HCl2. This is, you may find it useful to use Hess's law to construct an energy cycle. You may draw Hess's law cycle, and you see, first you see given first equation I write here. Sulfur dichloride reacts with chlorine to form HCl2. You see, then sulfur chloride dichloride is produced, sulfur acid plus chlorine. So sulfur dichloride is formed from their elements in their standard state. So here sulfur acid, this is the solid, sulfur room temperature is solid, and chlorine gas. So from this to this, 8 mole, 8 times enthalpy of formation of sulfur dichloride. Now you see, sulfur reacts with chlorine to form disulfur dichloride plus chlorine, and this is given here. HCl2, sulfur reacts with chlorine, sulfur reacts with chlorine to form H2Cl2. This value is minus 58.2. So here sulfur reacts with chlorine to form H2Cl2 plus chlorine. This value is given minus 58.2, and this value H2Cl2 reacts with chlorine to produce HCl2. This value is given negative 40.6, but here 4 mole react, that's why times 4. So now this is the direct route, this route is direct route, and this route is indirect route. You know Hess's law, change in enthalpy direct route equal indirect route. So direct route is this, 8 times enthalpy of formation HCl2 equal minus 58.2 plus this plus negative 40.6 times 4. So if you calculate 8 times this equal, you get this. So enthalpy of formation of sulfur chloride, you will get negative 27.6 kilojoule per mole. Now number 3, state the effect of decrease in pressure on the position of equilibrium in reaction to. Explain your answer. So if you decrease in pressure, equilibrium will move to the greater number of gas moles. Now in reaction to, you see, reaction to this solid, so greater number of moles on left hand side. So if you decrease in pressure, equilibrium will move from right to left, because there are more gas moles on left hand side. Now you see the answer. Decrease in pressure, equilibrium moves to the left. Moves to the left means right to left, as there are more moles of gas on left hand side, because left hand side has only one gas moles, right hand side no gas moles. That means left hand side has greater number of gas moles. That's why answer will be equilibrium moves to left, as there are more moles on gas on left hand side, or there are greater number of gaseous molecules on left hand side. Figure 3.1 shows two structural isomers of disulfur dichloride. This is the isomer 1, isomer 2. So you are asking, define the term structural isomers, and molecules with the same molecular formula but different structural formula are called structural isomers. Molecules with the same molecular formula but different structural formula. Now number 5, suggest a value of the chlorine, sulfur and sulfur, this angle in isomer 1. Explain your answer. So bond angle will be, sulfur is a group 6 element. Outer shell has 6 electron. So 2 bond form, 2 electron used, remaining 4 electron means 2 lone pair. So this angle will be 107. Why? Because there are 2 bond pair and 2 lone pair electrons in sulfur. Sulfur has 2 lone pairs and 2 bonding pairs of electrons, and repulsion from lone pairs is greater, means lone pair electron repulsion is more than lone pair bond pair, then bond pair. So you can write here 107 degree, or you can write any values, 91 to 108. That means 4 bond pair tetrahedral is 109.5, but as here there are 2 lone pair, so lone pair repulsion is greater. Lone pair repulsion is greater. That's why bond angle will be smaller than tetrahedral, 109.5. That's why you can write 107, or you can write 104.5, as there are 2 lone pair and 2 bond pair electrons surrounding the sulfur atom. So lone pair repulsion is greater than lone pair and bond pair electron repulsion. Number 6, draw a dot and cross diagram to show the bonding in isomer 2. Show outer electrons only, outer shell of electrons only. You see here double bond, so 4 electron, here single bond 2 electron, here single bond 2 electron. Now you see the diagram. Sulfur as here double bond, so 4 electron. Here single bond, 2 electron, 2 electron. So sulfur is a group 6. Here 1, 2 electron give, remaining 2 bond pair, remaining 2 lone pair, 4 electron extra. Chlorine group 7. So it gives 1 electron here, remaining 6 as lone pair, non-bonding electron. This is the dot and cross diagram of isomer 2. Next, number 4, organic compounds can be distinguished using chemical test. Table 4.1 shows 4 pairs of compounds. These are given, and you are asking complete table 4.1 to identify a reagent that could distinguish between the compound in each pair. Give the positive result of the chemical test and identify which compound shows these results. Use a different reagent for every test. So now you see, question is asking you A1 and A2. How you can distinguish A1, A2 by chemical test, by using chemical reagent. Question is asking you. So you know A1 is a star, S COO, both side has alkyl group, and A2 is secondary alcohol. So you can use potassium dichromate, or you can write acidified potassium dichromate. As you know, secondary alcohol oxidize to form ketone. So A2 makes solution turns to green. For A2, orange potassium dichromate solution turns to green, but for A1 remains same. So you can easily distinguish A1 and A2 pairs. Or you can write sodium is added. Sodium reacts with alcohol to produce hydrogen gas. So fizzing or effervescence is seen, bubbles of gas is seen. So A2 will gives bubbles of gas, but A1 does not. So you can easily distinguish. Now look for B1 and B2 pair. You see, this is the methyl ketone. This is B2 is star. So reagent is alkaline iodine. Sodium hydroxide plus iodine means iodoform test. So B1 gives yellow or orange PPT, precipitate, but B2 does not. Or you can write 2,4-DNPH, 2,4-dinitrophenyl hydrazine is added. So as B1 is the methyl ketone, so gives red PPT, but B2 does not give red PPT. So you can easily distinguish B1 and B2 pair. Let's move C1 and C2 pairs. C2 is a cycloalkane, this is alkane, this is alkene. So simply if you add bromine solution is added, or reagent aqueous bromine is added, C2 turns orange bromine solution turns to colorless. So for C2, orange bromine solution goes to colorless, but C1 remains same. So by aqueous bromine test, you can distinguish CO1 and C2 pair. Next, D2, D1 and D2. So D2 is a alcohol and D1 is a alcohol, sorry. D2 is a alcohol plus carboxyl group, two functional groups. So simply you can distinguish if sodium carbonate or sodium hydrogen carbonate is added, and for D1 no observable change, remains same, but for D2 as carboxyl group present, so D2 gives fizzing, effervescence or bubbles of gas. So by the reaction with sodium carbonate or sodium hydrogen carbonate, you can easily distinguish D1 and D2 pair. Next, C1 has melting point minus 94.94 degrees centigrade and boiling point plus 49 degrees centigrade. Melting point and boiling point very low. Explain these properties by referring to the type of van der Waals force between molecules. So C1 as C1 has very low melting point and boiling point, so C1 has weak van der Waals forces or weak intermolecular forces. C1 has weak intermolecular forces. Only dispersion forces have to break. Only dispersion forces have to break. That's why melting point and boiling point is very, very low. Next, draw the structure of the cis isomer of C2. Cis isomers means identical group located in one side, below or up. So if you draw this same group in one side, so this is cis isomer of C2. Hydrogen same group, if below or up one side, this is same side, same group, identical group, this is known as cis isomer. You see, this is the cis isomer. Here one hydrogen, here one hydrogen. So identical group are same side, this is cis isomer. Then C2 forms a polymer when heated gently. Number 1, identify the type of polymer that forms from C2. As C2 is an alkene, so it will form addition polymer. Number 2, draw one repeat unit of the polymer formed from C2. So how polymer form, you see, this double bond becomes single bond. Left carbon contains CH3 group, below CH3 group, one hydrogen group above, this bond open left hand side. Also right hand side, one hydrogen, then this contains CH2, CH3 bond open. This is the one repeat unit of this polymer from C2. Next, number 5, lactones are cyclic stars. Under suitable condition, cyclic stars this. Under suitable condition, lactones form from molecules that have both an alcohol and carboxylic acid functional group. That means lactones are formed from carboxylic acid and alcohol compound. Equation 1 shows an example of the formation of lactone. This is the equation 1. Lactone is formed to remove water. Figure 5.1 shows the synthesis of lactone P from compound M. So you are asking M, this is the M. M reacts with hot concentrated acidified KMnO4. This is the oxidation of alkene to form N. So molecular formula C6H10O3. In reaction 1, draw the structure of N. You see hot acidified KMnO4, you know reaction happen, carbon-carbon double bond break. So this carbon contain one hydrogen and one alkyl group that will form carboxylic acid. So 1 carbon, 2 carbon, 3 carbon, 4 carbon carboxylic acid. So 1, 2, 3, 4. Then this containing one methyl group, other methyl group. So this will form ketone CH3CO. CH3, this will be CO. CH3CO. This is the structure of N. How you get N? This breakdown here. This forms CH3CO. This 1, 2, 3, 4. 1, 2, 3, 4. 4 carbon containing carboxylic acid. Then here methyl ketone. Then next N is reduced by sodium borohydride to produce 5-hydroxyhexane dioic acid in reaction 2. So N is C6H10O3, C6H10O3 reduced to is added to hydrogen. So this will be C6H12O3. When reduced, 2 hydrogen will be added. This is the reaction 2. Then you are asking reaction 2 is a nucleophilic addition reaction. Suggest why reaction 2 creates a mixture of two organic compounds. And you see in reaction 2 N is the reactant, is planar. N is planar. Why N is planar? You see N here methyl ketone 1 bond pair, 2 bond pair, 3 bond pair. So molecule is planar. N is planar. So molecule N is planar. If a molecule is planar, then nucleophile can be attached from both sides of the molecule. So nucleophile can be attacked from either sides of the molecule. So different optical isomers form. If a molecule is planar, methyl ketone is a planar because there are 3 bond pair. So nucleophile can be attacked from either side of the molecule to forms 2 optical isomers, or so different optical isomers can form. Next, you see for lactone P, the product of reaction 3. So P is the product, reaction 3, 1, 2, 3, 4, 5, 5 hydroxy hexanoic acid. So how is formed? You see, lactone is formed 1 2 3 4 5 carbon, 1 2 3 4 5 carbon. This carbon is SCH3. So from this 1 2 3 4 5 hydroxy hexanoic acid forms this lactone. Total 6 carbon, 1 2 3 4 5 6. Here you see 1 2 3 4 5 6 carbon. And you see, use table 5.1 to suggest why it is difficult to distinguish between N and 5-hydroxy hexanoic acid using infrared spectroscopy. It cannot be distinguished because absorption peak will be same, absorption will be similar, as both have some bonds in the similar environment, both have similar bond. So you see, this is the 5-hydroxy hexanoic acid and this is the N. So this has OH group, OH absorption, this has OH absorption, same. This has carbon oxygen double bond, carbon oxygen double bond. This has OH peak, this has OH peak. So the distinguished absorption are similar. That's why I write here answer absorption will be similar as both have some bonds in similar environment, or both compound contains same absorption, same bonds. Next, see, unknown lactone Q is analyzed using mass spectrometry. Table 5.2 shows information from this mass spectrum. There M plus M by E abundance M plus 1 peak is given. Use this data to deduce the structure of Q. Show your working. And you see, first I have to find out how many carbon present, and this formula, number of carbon atom 100 divided by 1.1 times abundance of M plus 1 ion peak divided by abundance of M plus ion peak. So if you calculate, you will get 3 carbon atoms. That means that lactone contains 3 carbon. So you see 3 carbon containing lactone 1 2 3, as lactone contains star group COO. This is the answer, 3 carbon. Thank you dear students. Please subscribe, like and share my channel. Thank you.